In Unit 8, we covered a variety of different terms and learned what they were and how they were applied. I learned terms like the Doppler effect, Hubble's law, spaghettification, black holes, the redshift, and also like more about the Big Bang theory and another theory that came up along the way that could like go against the Big Bang theory. Almost everyone has experienced the Doppler effect and redshift, though perhaps without knowing what causes it. The study of light is called spectrography, and this is used in these two effects. By making careful observations of the light that a star gives off, or the light that is reflected from a planet, scientists can find out a lot of information about the distant object. This is the first part of the redshift puzzle. The second part of the redshift puzzle is a little more complicated. Here I have a picture. This seemed like a common topic that people talked about when I was researching it, so I use it as an example. We have all heard a police car with its sirens on go by, and you have probably also noticed that if the police car is moving toward us, the pitch of the siren is higher than it is when a police car is moving away. To make a long story short, this effect is what is known as the Doppler effect. The question that you have right now is, what does a siren have to do with a distant star? The answer is that the light behaves the same way that the siren does. Instead of the sound changing, though, the color of the light from an object changes by a very small amount, depending on whether the object is moving closer to us or farther away from us. By the way, an object has to be moving very, very fast in order for the light to change color even a little. So again, this is an example of the Doppler effect, because the change in the observed frequency of a wave when the source of the wave is moving with respect to the observer. Next, couple of topics I learned was spaghettification and black holes. Like the Doppler effect and redshift, these two are also related. Spaghettification refers to the effect of extreme gravitational pressure on any particle or body of matter. When a particle draws too close to the source of the powerful gravitational field, it is stretched into long, thin shapes like pasta. I have a picture of that. So here, the famous picture is like the astronaut being sucked in, and you can see he's being stretched out like a noodle or spaghetti. Another thing, here's also, this is with the black hole and spaghettification, black hole, and this is just the astronaut being sucked in, but of course he'd be stretched more. This is just like an animation thing. And next we have Hubble's law. Another thing in the unit was Hubble's law. More distant galaxies are moving faster away from us, and Hubble concluded that the fainter and smaller the galaxy, the more distant it is, and the faster it is moving away from us, or that the recession velocity of a galaxy is proportional to its distance from us. This explains that the observations of distant objects reveal the universe is accelerating as it expands, and it's also rapidly expanding. And this is one piece of evidence that supports the Big Bang theory, because the universe is constantly expanding. This is found in Hubble's law, which I just explained, and scientists can easily go back in time and see the universe as it shrinks and connect the dots. Another piece of evidence that supports the Big Bang theory is that the universe contains 75% hydrogen and 25% helium, which was the calculated amount to be the outcome if there really was a Big Bang theory. And it turns out years later that once it was calculated that it turned out to be 75% hydrogen and 25% helium. Another factor in our universe is an unseen one, known as dark matter. The universe consists largely of a mysterious form of mass and energy known as dark energy. The universe consists largely of a mysterious form of mass known as dark matter and a mysterious form of energy known as dark energy. One of the strongest pieces of evidence that supports the Big Bang model is the presence of a cosmic microwave background radiation, or CMB, and this is throughout the universe. All this really changed my view on the universe because I had no idea that all these different factors existed. I thought it was really cool too how the scientists could go back in time and recreate the universe, go back in time and piece together something like the Big Bang Theory happening and support it. Also, it's amazing that we need all these factors in order to exist as a universe and as life on Earth. Lastly, the four-dimensional view of the universe is really crazy and interesting. This goes against the Big Bang Theory. Instead of the Big Bang Theory, scientists are now saying that we could have just been the leftover elements of a four-dimensional star collapsing in on itself to form a black hole. Some scientists argue that the theory happened instead because of the limitations on the Big Bang. So, some of the scientists, mainly this is just the scientists that hate on the Big Bang Theory and say that there's limitations to it. So many of them kind of believe in this theory that a four-dimensional star collapsed in on itself and it created a black hole, and the remnants that were spit out became what we are today. So yeah, that was my stab at the four-dimensional universe theory. But yeah.